Welcome to Learn Yourself. Today we are going to study the periodic classification of elements. This chapter is under CBSE Standard 10 syllabus. So let us start our chapter from Dobereiner's triad. So here we are going to discuss four scientists in total. First is Dobereiner, then Newland's octaves law, then Mendeleev's periodic table, and then Moseley's periodic table. So all this were the concept at that time, and from that today's modern periodic table we have derived. In previous chapter we have studied that so many scientists have given their own concept with their own structure of atom. Those were the concept, and we have studied that how they have given or how they have proposed their structure of the atom and why those structure were failed, and how we have come up with today's new and correct structure. Similarly, we are discussing how today's new modern periodic table has been derived. So that we will study from four scientists. First is Dobereiner's triad, then Newland's octaves law, then Mendeleev's periodic table, and the last modern periodic table. So here we are starting with Dobereiner's triad. In this you have to study three things. First, how they have arranged the elements. Second, the concept behind their arrangement. And third, what are the limitations for their arrangement or whatever arrangement they have given for the periodic table. So Dobereiner was a German scientist, German chemist, who tried to arrange the elements with similar properties into group. So he tried to arrange whatever elements have been discovered at that time. Those elements he tried to arrange in specific groups. Groups were three elements in each, and that's why it was known as triads. Because in each group he placed three elements. So that's why it was known as Dobereiner's triads. How he has arranged this? In order of increasing atomic masses. The atomic mass of middle element was roughly average of the atomic masses of the two other elements. That means this was Dobereiner's triad, and in that he placed lithium, sodium and potassium, such that lithium and potassium's average, if you will take out, then and it will be roughly near to sodium's mass, and that is how he arranged three triads and total 9 elements. Again, he arranged three elements in such a pattern that if you will take average of 2 elements at each side, then you will get an answer, the atomic mass of, and that is roughly equal to the atomic mass of the middle element. So that is how he arranged these 9 elements. But he gave only 3 triads, and he has arranged in order of increasing order of atomic masses. This is increasing order, that from this atomic mass is more, and from this atomic mass is more. So that is how Dobereiner arranged 3 elements in one group. Another 2 triads he gave, that was calcium, strontium and barium. This was another triad, the second triad, and the last triad he gave was of chlorine, bromine and iodine. So this was the third triad. So this is first, this is second triad, and this was the third triad. In total he arranged 9 elements in 3 triads. Now moving towards the limitation of Dobereiner's triad. So these were the limitations of Dobereiner's triad. First is, method was not holding true for all the elements. He gave triads for only 9 elements, into that 3 triads. So it was not holding true for all the elements. Only some of the elements, only few elements he could arrange in this triad pattern. The second point is, properties of elements of group into triads were found not to be similar. So some of the elements which he has placed into triads, their properties were not matching with each other. He has only focused on to arrange element in increasing order of the atomic mass, and he has arranged us that middle element will be an average of the other two. But rest two important criteria were not hold true for Dobereiner's triad. So these were the main limitations of Dobereiner's triad.